Welcome to the Silicon Web Customer Skill Tech Couture webinar. This is our second webinar in the webinar series. We're offering talks by speakers on a variety of topics about costumers and costuming. These are free to Silicon Web members and also available to the greater costuming community on a space available basis. We have a limited number of seats, and so we'll give preference to Silicon Web members, then make it available to everybody else as well. So welcome, and we're glad everybody was able to come. If you have some suggestions on future speakers or topics, please send email to board@siwcostumers.org with the subject line webinar series, and we'll be glad to get your suggestions. The initial webinar series that you're participating in now is sponsored in part through a grant from the ICG Marty Gear Costuming Arts and Sciences Fund, and we're also using the Zoom platform available to chapters and SIGs. So a few notes on Zoom. Please leave your audio and video controls on mute. Feel free to chat or react during the presentation and the chat window, of course. There's going to be a Q&A period after the presentation. If you want to ask a question, type it into the chat window and label it as Q&A. Sahrye and Hal have also said that if you want to ask a question during the presentation, feel free to do that too. If you want to turn on your audio and ask a question, they'll be happy for you to do that as well. When the webinar is over, there's going to be a brief survey on your experience, and we'll appreciate you getting your feedback on that. So as an introduction, Sahrye Cohen is the founder and chief designer of the design studio Ampted Atelier. She teaches workshops on wearable electronics for costumers and cosplayers, and she's published articles in Make magazine and the Silicon Web's Virtual Costumer magazine. Hal Rodriguez is a maker and programmer, and he's the chief technologist of Ampted Atelier. He has more than 20 years of programming experience and has published articles in Make magazine. Ampted Atelier is a design studio specializing in tech couture designs that meld historical fashion and couture techniques with modern technology. The studio has been featured on runways of San Francisco, New York City, and Nashville in the US, Calgary, Canada, and for Fashion Week in Xiamen, China. Their most recent book, Make It, Wear It, Wearable Electronics for Makers and Crafters, Cosplayers. And for more information, go to amptedatelier.com. I'm going to turn it over to Sahrye and Hal.
Yeah, we'll get started. If you have a question, also feel free to put it in the chat and we'll try to address it. And then we will leave enough time for questions and answers and some show and tell at the end.
All right. So we're going to start our presentation. I'm going to share the screen. All right. Okay. So as Bill mentioned, we're Sahrye and Hal. We basically do tech couture as essentially a series of art dresses. I'm going to play a little video that kind of gives you a really quick introduction and showcases like some of our work. Oops. There you go. So we've been doing tech couture dresses since 2015. Sahrye has a background in costuming and fashion design, and I've been playing around with electronics and been working as a programmer professionally. And in 2015, we had the opportunity to be part of a tech fashion show in Canada. So the group is called Make Fashion. We sort of developed a relationship with them. They came down to the Bay Area for the Maker Faire. And in 2015, we created our first dress. So that was our very first dress. We had a lot of fun producing it. Then over the years, we started kind of taking our designs and kind of expanding on what we learned. So our first dress was essentially controlled by a cell phone. There's animation and the little field on the bottom. You could basically, with the cell phone, change the text on the fly. Then the next year, we wanted to bring a little bit more interactivity. So we created a pair of dresses using 3D printing on fabric for these little crystals. And then we added sensors, so now the models could actually interact with each other. And we'll go into a little bit more detail in further slides. In 2017, we took a break, but even though we took a break, we actually ended up creating 3 dresses. They were basically not full-on art dresses, but more kind of what we'd like to think of them as sketches. Just exploring different ideas. And we've essentially, since then put them on the runway and in some cases actually added interactivity. So these are basically us experimenting with concepts more than anything else, but in a more finished way. The last dress we did in 2017, we ended up taking and actually adding functionality, adding more interactivity with it. So this particular one, which started as a simple sketch for a dress, we ended up adding accelerometers into a dress so a dancer could actually perform in the dress. And then the last dress that we did is in 2019. We created a dress that can actually be performed. So this one was actually meant it actually has a music background, has music capabilities, and that the model could actually perform the dress. So we went from 2015, where essentially the model, the dress could be controlled from afar, to 2019, where the model is actually a performer. And then in 2020, the pandemic hit, and things we're slowly getting back up to speed. Now 2 years later.
So just a little bit about what we mean when we say tech couture. So couture is kind of a fashion style most often associated with haute couture from France, right? It has a specific methodology and membership. But at its very basic, what we're really talking about is kind of craftsmanship level. So couture, a garment that is made with couture techniques, means that it has certain finishing techniques where it encloses raw seams, where things are made by hand, where they're made to fit a particular person. And there's a focus on fine materials and durability. And I think that's one of the things where you can have this technology interact with the traditional fashion dressmaking techniques. So we make all of our projects, all of our pieces out of silks. We make them out of sequenced fabrics. We often use new technologies like laser cutting, 3D printing, things that take time and intention and effort. So all of our pieces are intentionally made not as fast fashion. They're finished on the insides, they're durable. And this is both to emphasize that technology does not have to be disposable. I think that there's definitely a sense that you're always upgrading, right? You're upgrading to the next cell phone, you're upgrading to the next piece of technology. and to really meld that with the idea of couture, where you're making a piece that is meant to last, that is made of fine materials. And so that is our intention, is to meld those two things together so that we're not making fast fashion. We're making pieces that have more of a timeless design, where they're beautiful both with the lights or music or interactivity, but also just as fashion pieces on their own, and that they are intentionally made that way.
All right, so let's take a look at most of these dresses one by one. So this was the first dress we made in 2015. It was called Reflections. The tagline was, "Everybody wants to have their say." Again, like Sahrye mentioned, we're trying to meld, old or historical fashion with modern technology. Reflections was inspired by like the highly structured garments of the Victorian era, and here it is in action.
Yeah, so we've got a sheer silk hoop skirt worn on the outside, right? So we've got that structural garment of 18th century or Victorian era that we brought into the modern era. And then also luxurious textiles using silk satin and silk organza.
Right, and technology, but it was basically using LED matrices that are displaying messages from a Bluetooth smartphone app. You'll notice that the model isn't currently having that. We were controlling the app from the sun. But that was something that was early in the kind of process. We basically moved to having the model or the performer control the process.
Another thing I like to think of kind of as my design philosophy is that my pieces are not just a forward presentation, that there's a back too, right? So I want to see that there's lights, that there's motion going on when someone walks away.
There we go.
All right, so our design process usually starts with a concept design, incorporating a specific technology. At the time that we made this dress, LED strips were starting to become more common, that we could get a matrix, getting a matrix of, and Hal will talk about it in our next slide. This was a new technology and we really wanted to use it. Similarly, controllers were just starting to be able to use Bluetooth. So microcontrollers that home hobbyists could use. That was a new bit of technology. And so we were really excited about using those two things. And you can see from my original design sketch, it had very much an 18th century look of kind of like a structured bodice and then a skirt with some hoops. And then I almost always make a half scale mock-up before I do. Sometimes I do it with costume pieces that I'm going to wear. I have a mock-up that's my size. But I always do it for runway pieces as well. And that's basically so I can play with the materials, see how they look together, and try out several designs. So you can see also that from my original design sketch to the mock-up, the design changed, and then even to the final piece.
Yeah. And part of the reason the design changed is because these LED matrices at the time were a lot more expensive than they are today. So the amount of LEDs that we had was outside the budget that we had for the show. So we ended up simplifying the design and working with more strips, but we still used two of these dresses on the bottom of the hoop skirt. These are LED matrices. They're addressable LEDs, so you can basically control them, and that's how we have the text scrolling on. They're actually full RGB. We basically chose a particular RGB is essentially red, blue, green. It's how basically the combination of those colors can get you a palette of, I believe it's like thousands of different colors, but we chose a specific palette for the dress. The matrices themselves are about 3 inches by 12.5, and again, we use 2 of them on the bottom of the hoop skirt. Just another picture of what the dress actually looks like. There's essentially 2 separate systems. The bodice, which is essentially part of the cocktail dress, because the hoop skirt it kind of attaches to it, is its own separate system from the hoop skirt, which has the addressable LEDs. The top is essentially a generative little animation with a little specific pattern, but it's never the same twice. It's always a little bit different. And the bottom of the matrix has the default setting, but we also, we can change it on the fly. So here's what the dress looks like without the hoop skirt. This is sort of what we refer to as the cocktail dress. And as Sahrye pointed out earlier, one of the things we'd like to do is make sure all our pieces are good when all the technology is turned off. So it's still a piece, and yeah.
All right, and so this piece is made out of a silk organza. And one of the things that helps me do is I like to use fabrics that are translucent so that they can hide the technology behind it. Most of the LED strips, especially when we started doing this in 2015, were not very flexible. They were on mostly white backing, so you could see them, and so they were not attractive. They were not maybe if you were going kind of for a cyberpunk aesthetic, but kind of going for an elegant mode. So I've always been very interested in figuring out what materials I can use to mask those electronic pieces. So in this cocktail dress, I'm using silk organza and then a silk satin. And again, I build all my pieces, these are interlined again with silk organza to make them durable. This is the bodice. And then the skirt piece here, I have technology. We have the technology, we have the wires coming out, but I finish all of my hems. And I also finish most of the pieces with kind of a Hong Kong finish or a hand-done hem in order to just protect the seams. We've occasionally shipped these around the world to other fashion shows. And so I found that not only does this make it more luxurious, but it also really helps the durability.
And here's the dress one last time in Hong Kong for Miss Chinatown International. This model was representing the San Francisco Hong Kong. I'm sorry, the San Francisco Chinatown.
One of the other things that we, have really thought about when we're doing tech couture is that these garments still need to be cleaned, right? So we've had a number of different models in different sizes, and for even a couture garment, you can usually take it to be dry cleaned, so it's cleaned with chemicals that are not water. But what we've done mostly is we've designed things so that they can be removed. So we have removable electronics so that we could then send this silk piece to be dry cleaned. Or other garments, we have removable liners so that those liners can be washable. So I think, if you're designing a costume using electronics, right? So what this picture is showing is you need accessibility, right? You need to be able to reach your power. You need to be able to reach your electronics. You need to be able to remove them if you need to fix them. And you need to be able to remove things in order to clean those garments as well.
So yeah, here the pedalum in the back of the cocktail dress is hiding electronics in a pocket. And here the hoop skirt has a the hoop skirt here has a pocket where you can, has essentially a Velcro pocket where we can actually get to the electronics. This was actually one of the shows where we had to do a little bit of troubleshooting, but because we had easy access to the dress, we could actually work things and get things up and running really fast. Over the years, because everything is modular, because we take, for things like cleanability, we've actually been able to upgrade some of the electronics as the years go by, some of the boards get smaller and more capable. So we've changed the electronics on the hoop skirt for the same functionality, but in a much smaller package. The cocktail dress on the bodice is still the same because it does actually work, but we've changed around how we do power. But yeah, it's actually one of my favorite dresses. All right, next, 2016. 2016, we explored printing on fabric, using a 3D printer to actually print directly on the fabric to have the essentially design elements on here. And a lot of what we're doing is we're printing with a semi-translucent filament. So with the light, with all the electronics off, it has essentially kind of a nice little soft white feel to it. They're not completely translucent. So it hides the LEDs that are underneath them. But when they're turned on, they have these wonderful colors. So here's kind of a little close-up of what we're talking about, 3D, what the finished effect of the 3D printing on the fabric looks like. So all these crystals that 3D printed on the fabric, they're all backed by addressable LEDs. So we essentially, and you saw in some of the earlier videos, that allows us to create, the dress could be whatever color you wanted it to be. And our initial version of this dress, we had a color sensor that allowed, that basically allowed the dress to mimic something that it was presented with. And we'll see that a little bit later, but let's go a little bit more into the 3D printing on fabric.
All right, so we know that we wanted to do 3D elements. And my original design sketch combined kind of a 3D printed lace. So I wanted to make kind of this floral effects and crystals that would be printed on a 3D printer and would either be attached to the fabric or printed integral with the fabric, and then using leather as kind of the other material for those projects. But the floral lace was really beyond our 3D modeling capabilities at the time. So right now there's many more software that is available, things like Blender, things that you can essentially sculpt. But at the time there was Tinkercad and a couple other design programs that we really used to get started.
Mm-hmm. So here we decided to go with a simpler element that basically these little triangular boards are individual pixels and individual little LEDs, addressable LEDs. They're not currently wired, but we decided to print essentially these little pyramid shapes that match the LEDs, so we can actually have them really tight together and really close together. And then once these were essentially we printed them just to size them. Then we printed them on fabric. Again, we're back at the half size model. So the dresses are half size, but the 3D printed elements are full size, and we're just kind of seeing how how they look against the fabric and some of the fabric choices. And this is actually printing. This is where we've actually taken the fabric, we've clipped it onto our 3D printer, and we're essentially building up the crystals. So the secret to doing this is we print a layer of the 3D model first without the fabric, put the fabric on top, and then continue printing. So because of the temperature, the plastic is essentially melted into the fabric, and what we've seen is, depending on the fabric will tear before we lose any of the 3D elements.
So it's turned out to be a very durable way to 3D print through net. So of course we could design our 3D printed models so that they have holes, we could sew them on, we could glue them on, but these dresses have been in use since 2016, and we've never lost any of the 3D printing.
Yeah. Oops. And then in 2017, we wrote an article for Make Magazine. They came up with a wonderful title of Print a Porter, where we basically describe that the entire technique of how we 3D to print in our fabric. It's also we also cover it as a chapter in our book. But let's see what the actual dresses work with the color sensors and how they're So we call these dresses mimic because of the color sensors. So she just used the handkerchief to essentially change her dress. So we debuted these dresses at the Make Fashion 2016 Gala. We've also because a lot of the electronics are modular. We've also used the dresses with like radio proximity. So as the two models would come closer together, colors could meld. We've done, what else have we done with these dresses? We basically added accelerometers to them. They're fun to play with. This is just a photograph because I really like the beautiful photography. And then in 2017, we started to experiment with asymmetry and then complex patterning.
So the inspiration for this dress was these wonderful books that, if you've never seen them, they're called Pattern Magic. They were only originally available in Japanese, but now they're all available in English. And they're just, if you are a fan of pattern drafting, they are just really interesting. It's how you can make flat pattern shapes to make 3D effects for patterning. And so one of the examples is this thing called a drop hole, right? And so this really inspired me to think about a black hole's gravity well. And so we decided that I would add one of these drop holes patterned through Pattern Magic on the front of the dress, on the front of the skirt, and then on the back of the skirt as well. And then we made what are called infinity mirrors. They're a strip of LEDs between a regular mirror and a two-way mirror so that it looks like the lights are continuing on into infinity. And then the top used our 3D printing technique with net to do kind of an asymmetrical design with 3D printing. So one of the hardest parts of this piece, designing this piece, was getting the infinity mirrors to fit into the pocket, into the hole that's on the dress. And so we had to recut those several times in order to get them to fit. And then also to take the wires and the electronics and run them through the skirt so that on the front side of the skirt, all you see is this kind of, complete design with no wires, where the hole in the dress just flows directly into the infinity mirror.
So we included pockets where all the electronics sits on the inside. So again, the pocket is big enough because at this point we were starting to use like cell phone battery, like really small cell phone battery USB drives as our power sources. And again, everything is we keep our electronics modular, so we can swap out the electronics. We've used this dress again with like accelerators for kind of motion-based effects.
So we had a question from the chat for the dress where the fabric is embedded in the 3D printing. Have you had any of the embedded electronics fail, like a light bulb going? And so all of these pieces, the electronics are actually added behind the 3D printing. Behind the fabric. So it is actually fairly difficult to embed the electronics directly into the 3D printing. We've seen a couple people do it where they will pause their 3D prints and then add LEDs in. But it's actually, one of the things we do is we just 3D print the fabric. So for example, on the screen right now, we have these turquoise pyramids that are printed on the fabric. And then we will essentially just use a hot glue to bond the electronics to the backside of those translucent pyramids. And that does enable us to fix any of the LEDs that have gone out. So they're actually pretty robust, especially newer versions of these addressable LEDs. They have much more flexible wires than when we started.
Yeah, and it's usually not a problem with the like the little tiny circuit boards that enclose the LEDs are usually, it's not the problem that they fail, it's usually the connections. So we're wiring a string of LEDs, individual LEDs as little tiny circuit boards. We're wiring them all together. We can potentially get a failure in one of those connections. But since we said, we actually put it behind the fabric, and we still have access to the electronics that way. A lot of the dresses also have like a what's the word I'm looking for? Like a shift, like an underlayer. Yeah, an undergarment that essentially sits between the model and the electronics.
We do liners,
yeah,
often, so that the electronics aren't directly touching anyone.
Yeah.
And then in 2017, we did a series called Hyphae that was inspired by mushroom, fungal hyphae. And so this, we were really using laser cut fabric backed with electroluminescent tape. It's extremely hard to photograph. And interestingly, the electroluminescent tape, which is like EL wire, if folks have used that for costuming before, it is, what is it? It uses AC. So you actually need an inverter. It's a little bit harder to run material off of, but it is very bright in darkness, and it can look great backed with laser cutting. But again, these strips are very inflexible, so we did find that we were getting a lot of breakage with these as opposed to the LED strips. And so I wouldn't necessarily recommend using electroluminescent tape for anything that needs to be flexible.
Yeah.
And we got a question of what type of 3D printing plastic do you use? It has to be a semi-transparent diffuser to spread the light around if it's behind the dress fabric. Yes, so we 3D print directly onto net fabrics. So the sequence is actually a sequence net. And we are using a semi-translucent PLA for most of this. Go ahead.
In 2017, we also created the accelerations jumpsuit. The acceleration jumpsuit, it was again just a dress we basically the matrices, both vertical and then. But in 2018, we went to the show. We took the dress we had created the year before, but this time we added accelerometers, and we partner with a dancer who essentially performed with the dress.
So an accelerometer is a sensor that can measure basically measures gravity, but what it can do is it can measure movement. So it can measure the change on an X, Y, and Z axis. So in this photo, our dancer here is wearing the accelerometer on a wire down to her wrist. So she's wearing it on her hand. And as she moves her hand around, that's how she's controlling the lights and the speed of the dress,
right,
or the jumpsuit.
And because everything is modular, we could also use like the sketch that we did for the original Bluetooth, the reflections, where we actually can scroll text. We also adapted it for this dress as well. Here's some early parts of the process where we were experimenting what the actual dress would look like. And then these are essentially the custom matrices that we developed for the vertical front of the dress.
So in this circumstance, there wasn't a commercial product that was available. There was a matrix that we could use. And so we usually use the matrices to scroll the words. In this case, we needed a certain size and length, and so we had to create our own out of these very densely packed LED strips. So when we started this in 2015, these LED strips would have probably been at least $100, maybe a couple hundred. And these are now something you can get for maybe $50 for a meter. So the prices come down incredibly.
Yeah, the matrices we used before were upwards of $100 originally, and now you can probably find them for, we haven't checked recently, but we've seen them as low as like $20. So there definitely, things are becoming more affordable.
Right, and this is what we finally settled on for the design of the jumpsuit. Again, this is a silk charmeuse, right? So we're getting this lovely flowy design with the silk charmeuse, and then the silver sequins fabric is actually a net. So when the lights are off, you can't see the electronics at all, but when they're on, it's semi-translucent, so you can see all the electronics behind it.
So what's also interesting is the electronics have also gotten cheaper, but the programming interface has gotten also very interesting as well, and a lot more user-friendly. So in this next slide, we're going to do a little video. It's fairly short about we're using a product called Baconics. At the time, it was called Rocket Life Light Designer. But you can see that you can actually create really interesting effects just by dragging and dropping. So we start by importing a photo and then laying out our LEDs, superimposed on the photo, so we have an idea of what the animation effects would look like on the finished piece, which is a wonderful idea for software. It's not our software. It's we've had contact with the folks who make the software, and we really like it. Prior to this, essentially, I would actually be writing the code for to do all these animations, but it has pre-built effects. As you drop things, you can actually see what it looks like. So there's a lot of parameters that you can use to change the effects, but the real simple things, the simpler things, is just basically choosing a base set of colors. And this is actually done on a desktop, and your finished animation is then loaded via Bluetooth onto the actual board that runs on the piece. So it is definitely a lot of fun to use.
Yeah, so the question is, what do you use to plug the controller in? And the great thing about all of these new boards, here's an example of how it's working. It has this controller called the Lightbox, but there's many different controllers now, and they function through Bluetooth. So they're communicating with your piece through Bluetooth. So you don't even need to plug it in anymore, right? You've charged your board up, you plug your board into it, and then it's wirelessly, basically, through Bluetooth connecting.
Yeah, and it has, and we've used it on a couple of different projects.
So the Baconics is a great program for this, but it is not the only one. So there are many other Bluetooth controlled boards now that are starting to have kind of these interfaces that you can use.
Yeah. All right. So in 2019, we did a dress called Conductive Melody. And Conductive Melody is, when we were coming up with the dress, we decided to go to social media and interact with our sort of growing audience of followers to help us out with the various pieces. So we basically ran this, I think it was on Instagram. So we ran like a little poll, and the blue silk is the one that won, the blue silk taffeta. We also for like the first time, we're sharing our progress as the dress was completed. Yeah, we were trying to engage with our followers.
We're not great at the social media. And again, this is an example of how I am finishing all of my electronics and pieces inside, right? So one of the hallmarks of couture work is the seam finishes. So in this instance, I am using a bias tape to finish all of the seams. I'm also putting all of my electronics on a separate net that is then snapped or sewn onto the final piece. And that way I can easily remove those electronics if they need to be fixed. And then also if the piece needs to be washed or dry cleaned, the silk and the sequins are going off to the dry cleaner independently of the electronics. And so I'm also using horsehair for those folks who do historical costuming. A lot of the techniques we use to stabilize hems, I use a lot of those also to finish these sorts of pieces. And the really interesting part about how we developed this is that we made a custom fabric. So we've gotten really interested in capacitive touch sensors. So this is when you're using your hand to control devices.
Like your cell phone.
Like a cell phone, right? And so one of the ways you can do this is through conductive materials like fabrics, like a conductive thread that's made out of silver or steel or copper, right? So those are all conductive metals. And so in this instance, we're using a fabric that has conductive metal in it. It's copper colored, it's not entirely copper. And what we've done is we have fused that conductive fabric to a fusible backing, so kind of like an interfacing that you would use. And then we're using a laser cutter to make a design. And we're cutting this very intricate fusible fabric that goes onto our silk sleeve. And that's what's shown here in this left-hand photo. And so this capacitive touch fabric has now become our interface. So instead of pushing a button, like a tactile button or turning a knob, this piece is going to be controlled by touch.
So yeah, so if you were to count those little vines that are coming down the sleeve, there's 8 of them. And the idea is that we're basically on the laser cut copper fabric is essentially our eight keys, or 8 musical keys. They're being picked up by a sensor and a small Arduino, which basically when one of the little motifs on the sleeve is touched, will affect the lighting that's on the dress, but will also send a message to a Raspberry Pi that is running Piano Genie. And Piano Genie is a machine learning model that can essentially take those 8 presses, those 8 keys, and translate that into a full 88 piano keyboard, and would play essentially something that sounds melodic. It's not gonna create you a finished piece, but it'll actually create something that sounds musically interesting. So if you were to press the same element twice, you would not get this necessarily the same note. You would essentially produce something that's a major third or a fifth up, so something that sounds good. Based on the machine model that was done. And then all that was essentially pushed out through wireless audio. As an idea of what it would actually sound like, there's another short little video. So we worked with the background track, which is that underlying repeating rhythm. And then the music that's overlaid is essentially the generated melody.
So one of the questions in the chat is about how long the batteries last. And so you can kind of see the iterations that we're going from some dresses that just use lights to ones that use lights and microcontrollers that are Bluetooth controlled, to this final dress or piece, Conductive Melody, which is using lights, a microcontroller, a Raspberry Pi, which is a small computer. And so we are using progressively larger batteries for each of these. So we started off with very small lithium polymer batteries. They would maybe last for 3 to 5 hours running something with a microcontroller and lights, to now we're using 5-volt power banks. So kind of the things that you would recharge your cell phone with, like little lipstick ones. And then this Conductive Melody piece, because it's running a Raspberry Pi and it has a lot of power needs, it's running like a very large power bank. I don't know.
Larger than, it's about twice as large as your phone, but it's enough to power the dress for the entire evening, and all the electronics completely, and it's just one. And they're nice because they're essentially they're rechargeable, and they're actually a lot safer than just using the actual
the lithium polymer batteries were they're bare, so we would have to 3D print cases for them, and they can be dangerous. They can be punctured and catch on fire. So we've over time gone to a much safer power usage. So along the way, we've also experimented with other kinds of materials and techniques. This is a fiber optic fabric. When we initially made this dress, I think back in 2016, this fabric was about $70 for just this one panel. And now I'm seeing kids on YouTube or use 10 yards of it. So it's come out down amazingly in price. And what it is a loosely woven polyester or nylon fabric that has plastic fiber optics running along one way, either the warp or the weft. Somebody who knows can correct me which side that is. And then all those fiber optics are gathered into a bundle, and you can place an LED, and those and the light will filter down through the fabric. So this is really nice. It uses these very ethereal designs. It only works in low light. Even if you're using really bright LEDs, it's very hard to see in daylight. So if you were going to create kind of a fairy tale dress or a ball gown, it would need to be best seen in low light.
Yeah, the picture on the left is actually lit. It's really kind of hard to see it in a daylight, in bright light conditions. And it's also, as you can see on the picture on the right, it's also hard to photograph.
And one of the things we did do is we looked at all these materials that were available when we were writing our book, Make It Wear It. And we tried to come up with accessories so that people could do a sampling. It's a DIY project book, right? So that people could do a sampling of these techniques. So an example of a project that we used for the book is this fiber optic fabric scarf that has an overlay of laser cut velvet over it. So in this way, we're combining kind of more of a traditional fabric, a velvet that's used a new technology, laser cutting, to cut it with this new fiber optic fabric. And it kind of combines the fiber optics with it's shining through the holes and at the ends of the scarf.
Yeah, on the bottom picture, you can actually see the little gold little tube there. It's actually the bundle where all the fiber optics are gathered in. On the top photo, you can see that, this scarf is actually run by a single LED. We also did a hunt to find the brightest LEDs that we could find, because we're running them off from just a single 3-volt coin cell. But it definitely mattered the LED that we threw at it. And so we looked for essentially the brightest LED we can do, and that's what we recommend, because otherwise it'll be harder to see. We've worn these scarves to things like the Autumn Lights Festival in Oakland, and they're great. They're really kind of wonderful to use. But again, nighttime events is your best bet.
Yeah, and so these LEDs, the question in the chat is, do LED strips come with different sizes of lights? Yes. Especially now, there have been, just a profusion of LEDs that you can get, even addressable ones. So we've started to see kind of the little tiny fairy lights as addressable LEDs, down to kind of our regular 2812. And so those are maybe, I would say, a quarter of an inch square LEDs. And then these little dome LEDs come in typically 2 millimeter, 3 millimeter, 5, 7, and 10.
Right.
All right. And then this is another example from the book where we're also using fiber optics. In this case, we bundled the fiber optics into a 3D printed holder. And this 3D printed holder is over one of those addressable LEDs. So we're using kind of the exact same technique. We're using a fiber optic bundle. We're putting the light through it. Either it's for a light from one LED, or in this case, an addressable strip of wires of LEDs. And then we're able to control this skirt with microcontrollers. And when we refer to the book, this is the book that we're referring to, Make It Wear It. So this is where it's kind of a project book and an intro to 3D printing and LEDs for making projects. So I also wanted to talk a little bit more about using these techniques in costuming. So this is a photo of me wearing the jellyfish dress from Aquaman, right? So Kim Barrett is the costume designer, and here is her original design sketch for Mera's jellyfish dress from Aquaman. Here you can see an example of it from the movie, right? So it's mostly CGI, right? These jellyfish don't exist in real life, and the glowing elements on the dress don't exist in real life. So what does exist is kind of this coral-inspired sequence gown that she's wearing. The bodice part exists, but none of the lights or effects exist. So what I first did was I used kind of our traditional cosplay techniques of using foam. This is a translucent foam. And I've got just the same LED strips that we're using in Reflections or some of the other dresses that you've seen so far. I have a strip of LEDs underneath at the bottom of this jelly, and they're just facing upwards. In this photo, you can also see the power bank that I'm using for it. So this is essentially kind of what's called a lipstick. It could easily fit in your purse. This is a 5-volt power bank that I'm using for this.
This is the finished piece.
And then this is the finished piece. You can see that I have 2 separate pieces here, right? So I have these jellyfish that I'm wearing on a back piece. Those are using a microcontroller that's, using Arduino to control those colors. And then I have a separate piece that I'm using the skirt. And the skirt has about 100 LEDs in strips. And then those are being diffused by a nylon netting fabric and then kind of this polyester organza. And I'm using the light box. So the example that we showed with the jumpsuit of how you can use kind of the design interface and put it over with Bluetooth. In this case, I've got a special program.
Atlantean fish.
Atlantean fish is it's called. That I've just put the little blocks of color together and the effects, and that's what's running all the 100, it's at least 100, it might be 200 LEDs on the skirt of this piece. I'm running it from that Rocket Life or Baconics light box. There was a question in the chat about whether we've had problems with some polyesters that are prone to static and clinginess, whether we've had any shorts or issues with the electronics. In most cases, none of our electronics are bare wire. Like, they're all insulated wires. We enclose all of our microcontrollers into 3D printed boxes or pockets, so that none of them are in a place where they can randomly receive sparks. We often help insulate joins, both for stress relief and for protection with hot glue, or heat shrink. So we're intentionally designing these pieces so that they have less stress and impact from the outside environment. But this is just an example of how we're using the exact same techniques that we're using from our Tech Couture to move those into kind of just a costuming space. So exactly the same microcontrollers using Arduino and the addressable LEDs for the jellyfish, and then this Bluetooth controlled light box.
Yeah. Another question is, have we used LEDs framed with foil to increase their visibility? We actually haven't had a problem. A lot of the LEDs that we use are super bright. So occasionally we've turned them down to try to find the balance between extending the battery life and visibility, but it's never been a problem. The nice thing with this, the Biconics remote controller that you see on the screen on the right, is that you can actually set the brightness as well as just turn the LEDs off. So like the couple of conventions where Sahrye wore the mirror dress, it was convenient that if we're to turn the dress off, to change the brightness based on like the light setting, yeah, it's the newer LEDs can actually be very, very bright. A lot of times when we're working with these on our work table, without any of the backing, while we're trying to come up with the animations, we have the brightness down really low because they actually can be blinding.
I would say that what we're mostly looking for with LEDs is diffusion. Is rather than increasing the visibility, we're trying to diffuse them to get the different lighting effects that we want other than a single point of light. And then here is another example. This video shows just some very simple fairy wings that are using the fiber optic technique. So similar to the starlight skirt and the scarf, these are just bundles of LEDs that are put onto a very simple controller. This one doesn't even need to be programmed. It has a little Bluetooth app for your phone. You can just spin the color wheel and pick the colors based on that. There are some very simple ones that just have one or two buttons that you can press to choose the colors. So there's certainly a lot of options out there that are using essentially the same components, addressable LED strips, a microcontroller either that you program or that it comes with programming, and then you're just assembling them to get the effects that you want. And then I'm going to click over and just to show you that this tutorial is available on YouTube. And I think we could probably put the,
We can put the link on the tutorial online.
So there is,
yeah, it's 40 minutes long. so we're not going to play this video.
So if you are interested in using kind of, a first step into making, just fiber optic fairy wings where you're using fiber optics and these LED components and little microcontrollers and batteries to make a costume project. This is a nice simple one. All the components are available online. And so it's kind of a good introduction to trying to make a project like this. All right. All right, and then the great thing about microcontrollers is that they don't only make things light up, so they can also make things move. So getting into moving fairy wings is something I've been into during the pandemic. So I think I've made 3 or 4 sets of animatronic fairy wings so far. This is just a little bit video of one of the sets, and these wings are modeled on cicada wings. So most of our projects use light because fashion is a very visual medium, right? So we started using light as kind of our main output. And then Hal really likes sound, Hal likes synthesizers, and he likes electronic music. And so that's how we kind of moved into conductive melody. And then I really like making things move and really like fairy wings. So this is actually a project that we built. There's a company called Adafruit that makes a lot of hobbyist electronics, and we really support them. They have fantastic components and fantastic tutorials. And they actually designed this project. They designed a 3D printed or laser cut base, And so we have a 3D printer and a laser cutter and electronics. And so this is what the components behind those fairy wings look like. And so this kind of fairy project, if you want to put it that way, it combines 3D printing, laser cutting, electronics, and kind of traditional garment construction to make the rest of the fairy dress. And here is an example of a laser cutter. So this is our laser cutter, and I am testing some designs. So I have some miniature fairy wings that I'm cutting out before I cut my full-size wings. I'm just cutting them out of cardboard. And so this is one of the things we do with kind of the new technologies of 3D printing and laser cutting, is that we can prototype things before we build our final iteration. So this is just, you know, a cardboard box before I dump it in the recycling, and I'm cutting out the veins here. And then I'm going to use an iridescent plastic to make the membranes of my wings afterwards. So it's just, you know, example to see how it's going to work. And then here's the final design. So I've combined these larger butterfly wings that are made out of cardboard, mat board, and some wire and iridescent plastic. And then here, I'm gonna switch Peter to Hal. Hal can answer some questions. And then I combined it with a fabric that I got from Spoonflower that has monarch wings to kind of make a fairy costume. So one of the things I've been working on recently is building larger, heavier fairy wings, right? So the servos, the motors that I'm using are called servos, and they're being controlled by the microcontroller, and they can only lift a certain amount of weight. So these wings are actually pretty lightweight. They have the mat board as the internal structure, and then the plastic that's iridescent, and a little bit of wire to help them maintain their shape, aluminum wire. But they can't lift bigger, more complicated wings than this. So I've been working on designing wings that have larger, heavier motors that can lift bigger wings. So that's kind of the projects I've been working on recently, are making things move with microcontrollers. And then other projects that we've been working on, we're still very interested in using conductive materials. So I have an example here of a small project I made using conductive thread to make pom-poms. So these are cow pom-poms. So these cow poms are just using conductive thread and just regular acrylic thread or acrylic yarn. They're attached to an oscillator that's hooked up to a speaker. And depending on how much contact I have with the conductive material, they have different resistance. And then that affects the voltage going into the oscillator, which then translates into the frequency. So they kind of, you can squeeze them and they sound kind of like they're mooing, right? So it's a very simple design of using an oscillator to get a frequency and attach to like this little cardboard speaker behind the pom-poms. But I've just really been interested in using this conductive fabric. So another project I've been working on is using the conductive fabric that we used for the conductive melody dress to put into tulle pom-poms, and using those as our capacitive touch interface. So you can see that I'm touching this pom-pom and it's changing the program. So I have a sparkle program going on this cuff. That's one of the projects in the book. And then when I touch it, I get a rainbow program. So, you know, again, I've got the conductive materials mixed in with my tulle pom-pom. And then also working on diffusion. So here I've got a small microcontroller called the Adafruit Circuit Playground Express. It can be programmed with CircuitPython, Arduino, or MakeCode, which is kind of a code block program that's easier to do than traditional languages. And it's got these LEDs, and I've got a tulle pom-pom that I've got on top of it, and I'm looking to see how it diffuses the light, right? So these are kind of a way of combining, again, like textiles, fabrics, with the electronics to make a design hole. And what we're doing here is we are testing out both the conductive pom-poms and kind of the traditional pom-poms that we're intending to diffuse LEDs into another half-scale design to see what kind of design we want to go for. So my intention here is that this pom-pom dress would have the conductive pom-poms as the interface that would change the programming. And then the regular pom-poms would be lit. And it could also, similar to the conductive melody, you could control those pom-poms. Those pom-poms can control sound in addition to light. So this is just another variation on some of the techniques that we've already used to make a piece that is combining both light, sound, and capacitive touch. The other pieces that we're working on are a series of environmentally themed dresses. So professionally, I am an environmental scientist. And this first design here on the left is a sea level rise dress that this is the concept art for it that would use geographic information system data to do a simulation of sea level rise over a time series. So let's say over the last 50 years. And we could take the model and position her around San Francisco Bay, and it would demonstrate where we would expect the sea level rise to increase to. There's another design here that would be showing CO2 level rise, where we could use 3D printed parts to kind of increase and decrease the growth on the dress to simulate different CO2 or particulate levels. And then there's a piece that we are currently working on for a fashion show called Future Oceans. This is a group that is involved in plastic pollution advocacy. So what they are doing is they're working with a number of nonprofits to both work on a more sustainable fashion model. So a model that doesn't introduce additional amounts of plastic pollution into the oceans. So more sustainable fashion, and then also kind of these wearable art dresses for fashion shows to kind of raise awareness of this issue. So for them, we're making a dress that is using recycled plastic for the decorative elements. And then we're going to use programmable LEDs in conjunction with that recycled plastic to demonstrate the increase in plastic pollution in ocean gyres over the last 50 years. So again, we'll use a microcontroller or a Raspberry Pi computer to be able to program those LEDs to give a visual, to basically visualize the increase in plastic pollution in gyres over a time set. And so that will just be repeating during the fashion show. And we'll show the increase in plastic pollution amounts. And again, using recycled plastic as an element. And then this will be paired with some custom printed fabrics that are using cyanotypes of algae. So we're basically using kind of custom fabrics mixed with recycled plastic and electronic components to tell the story of how plastic pollution is affecting marine environments. All right. So I know that was a lot. Thank you for coming with us on our journey about how we're doing tech couture and then dipping into costuming sometimes with those electronic 3D printed and laser cut components. We are available for questions if you have questions, and we also have some show and tell if people have specific questions about some components. So I guess we'll take ourselves off of slideshow and go back into just regular screen mode for that. I think you want to stop sharing.
Oh, there we go.
I turned off the video.
All right, yes. So there was a question about whether the fairy rings also need low light too, and the answer is yes, because they're using fiber optics. Fiber optics look much better in low light conditions than they do in daylight conditions. It's just the nature of like the way they work. Because fiber optics mostly try to do channel light all the way to the end. But the way you get the little spark in the bed is that they're basically little nicks in the actual fiber that allow the light to leak out. Yeah. Somebody had a question about fiber optic bungles that they're waving around in an event. What's the quality of those? I was thinking that maybe having them be here for a costume. Yes, yeah. The Sahrye is actually holding some of those up. They're probably about the same sort of quality. Now, just so we know, the fiber optics that you're using for your fiber optic communication channel that's coming into your house, that's actually real glass. What we're talking here is plastic. So the stuff that's in the wire coming into your house for your super fast internet connection is very brittle. So you can't you can't really use them for a lot of the events that we have. Also, even the plastic ones can be brittle. We've had through wear and tear, we've had them also kind of break off like little pieces of them. That's why we usually use them in bundles. Have we combined lights with jewels for extra sparkle?
We have. And then we have a friend named Maria who that's kind of her hallmark. So if you were going to combine LEDs with jewels for sparkle, you need to look for rhinestones that don't have backing, or you need to scrape the silver foil backing off the rhinestone. If you just put it right up against the foil, it won't be able to penetrate usually. So yes, you can combine 3D printing and rhinestones, and you can put, if your rhinestones are large enough and they're transparent on the back, you can put them directly on LEDs. Most of our LEDs, we've never had a problem with them getting too hot. Sometimes people use super powerful LEDs that can get warm, but those are harder to find. We've never really had a problem with too much heat. Yeah. Mostly because the amount of batteries and microcontrollers we use are at most controlling a couple hundred LEDs. Right. So we're not talking about an entire Burning Man structure worth of LEDs that you need like heat sinks for. So we're never really getting that much power and heat that's being generated. That being said, were you to turn on a couple hundred LEDs to full white brightness, they could conceivably get a bit warm. But we've never had a problem with anything, catching on fire or hurting anyone.
Yeah, there's also, you've also embedded LEDs in resin.
Yes, we've embedded LEDs in resin and not had any problems with that. So those, we've embedded individual, just dome LEDs. We've embedded some LEDs from, so these are little fairy wings. Little fairy wings.
They're being washed out.
They're being washed out.
Yeah. They're all sorts of colors you can't see.
Yeah. And then we've seen some friends who did kind of induction, where you can the way that phones charge through induction charging, where they're within like the coil of copper. I don't know how induction charging works, but you can light up LEDs with that. We've seen people embed things in resin and do induction charging.
There's a question is, what is the typical construction design time for a single dress / costume? Is it the electronics or the dress construction that takes most of the time?
So we typically try to do those both at the same time. I would say that I probably do spend more time doing the garment construction. So I mostly do the garment construction. I'm very good at soldering, so I'll do a lot of our soldering if that needs to happen. Typically, we think the electronics are going to be easier than they are. And we spend a lot of time troubleshooting electronics in terms of the programming. So I would say the mirror dress is one of the ones that I did in the shortest amount by the time I decided that I wanted to enter a competition. And so I had a very short timeline of, I want to say, a month and a half that I worked pretty dedicatedly on that. And that was almost entirely because of the construction. I had to essentially combine a couple kinds of beaded fabric together to get the effect I wanted. I had to build all of the foam parts. And so for that, we just used two technologies, both the Arduino LEDs and then the light box using Bluetooth that I already knew how to use. I think for the gyre dress that we're currently making, it's supposed to be ready for a fashion show. We need to be finished by the end of April. And I'm already a little bit anxious about our time frame.
So there's a quick question about where are the batteries on your earrings?
Oh, where are the batteries on my earrings? So these earrings are made by a group called California Steam. The guy who makes them is local to the Bay Area. And there's two large.
That is pretty big.
Yeah.
Look at that.
I mean, they're what is it? Hearing aid batteries. There's two thick hearing aid batteries on the back. So they're still reasonably comfortable.
Mm-hmm. There was another question about translucent foam. Do you have to order it online? Where do you get it?
So I get it from TNT Cosplay. They have a specific name. So Hal will put that in. It is not EVA foam. It is the kind of foam that if you order like electronics or something and they get shipped to your house, it's that kind of white foam that's a little translucent. They have a specific name for it at TNT Cosplay. I don't honestly know exactly what kind of foam it is, but it is not EVA. But it's really great for dispersion for LEDs.
Yes. Yeah, and there's actually wonderful work being done. Sahrye actually has a piece of LED jewelry that actually has no battery and is just using these little tiny solar cells and like large capacitors, not super large, like large for jewelry, I should say, capacitors that it can essentially just charge in daylight, and you can run it for an evening and no batteries. And I think I'd like to get to the point where we're making something like that in one of our pieces.
We've made solar backpacks. So one of the projects in the book is a solar backpack, and we've updated one on Instructables. We have an Instructable out for making a solar backpack that can run lights or charge, run LED lights, I should say, right, or charge a phone. Mm-hmm. And so we'd like to get to a place where we can do an entire project that's run off of solar power. Yeah. So the reason we did a backpack is because we're using the efficient solar panels that we're using are pretty stiff. There's the smallest one I think we have is maybe about 3 or 4 inches, like 3.5 inches square. In the backpack, we're using something a little bit larger because we want to charge the battery that can both charge a phone as well as run some LEDs. Yeah. And yeah. Anything else you want to show? So I know there was a question about kind of the LEDs that we're using. Kind of the size. So I did just want to just show this strip. So this is just a strip. I just ordered these off the internet. And I use these, I'm making a series of unicorn hoodies for myself and my sisters and my nieces. And this is a case of matching the audience with the electronic needs, right? So my sisters and my nieces are not planning on programming or other way controlling these LED strips. So they just need something really simple. So I'm just using this the strip that I ordered off the internet that comes with a very simple LED controller that they can control through their phone. And so there's no programming involved. They're just going to control it through an app on their phone. And so if that's the kind of thing that you just want to add some lights, you want them to be a specific color, but you don't necessarily want to control the effect. You don't need them to do like a raining effect or a fire or anything or a water effect. There are many different ways that you can just order these off Amazon. There aren't a lot of local places to purchase this stuff anymore because there's no more Fry's or Radio Shack. And so there's a lot of really simple ways to add lights into clothing or costumes.
So on that note, there's a question about what are the best online outlets for LED costume supplies and accessories?
So I would say if you want to DIY, without a doubt, Adafruit is our top recommendation if you would like to start adding lights and lights to your costumes, movement to your costumes, any of those effects. Adafruit, absolutely, they have a bunch of costumers who write tutorials for them. Bill Burgess, Aaron St. Blaine, they're both costumers. They write tutorials for Adafruit. So they kind of know the use case.
Yeah.
They know what people are looking for. So, and their products are really good. So both SparkFun and Adafruit produce a lot of their own products, and they're made here in the US, and they work really well.
Yeah. So what's nice about both these websites is that they not only provide you the the LEDs, the microcomponents, they also give you information to get you up and running with these products. And then in both cases, more so on Adafruit, they provide tutorials for a variety of different projects that you could use with a lot of the components. So if you wanted to make a unicorn hoodie, you could probably find a project that's close enough on Adafruit that you can get the supplies and then just follow on the tutorial, but not making necessarily the whatever it is that they're making. It might be a headband, but you could translate that into a unicorn hoodie.
Yeah.
A lot of wonderful information is available there. They'll sell you both their own custom products as well as, like, they're not making their LED strips, right? They're getting them probably from wherever they're being manufactured in China, but they'll get them for you. But they'll carry the LEDs in different pitches, like how many LEDs per inch, as well as how thick or wide the LEDs are, as well as the form factor. LEDs can come in like in the matrices that we've come from in different sizes. They come in rings in different sizes and all sorts of different little form factors.
Yeah. Otherwise, if you're just going to order kind of like fairy lights, like these are just little fairy lights, they're probably going to be washed out too.
Yeah.
Like a little string of fairy lights. We just order those, off Amazon or AliExpress, to be honest. And they're a nice, easy way to add really simple lights. Obviously, you can't control them. They're the color they are. But yeah, we don't have any special supplier for these that are really good. We're just ordering like everybody else off Amazon or AliExpress for those. We do buy when we do use EL wire, we buy it from Cool Neon over in Oakland. They're on Mandela Parkway. They just make a very good product, but we typically don't use EL wire that much anymore. We used to use it a lot for Burning Man because it's nicely insulated from dust, but it has a really high power needs, and we mostly use LED strips now in different form factors.
Yeah.
Any other questions?
Any other questions?
Very cool. Thank you so much, guys, for doing this. This has been a really great presentation. I always have a lot of fun when you give lectures.
Yeah, no, it's definitely fun. We definitely learned over the years as well. Just so you know, when we first started, the very first dress that we made, we basically followed an Adafruit tutorial that was for, I think, a top hat. But we decided that we weren't going to make the top hat. We were going to, make that dress. And, it definitely got us started. But, it's not the same project. So we ran into things that, would work in a hat, but didn't work in a dress. And we adapted from there. But it's definitely a quick way to get started. Yeah.
Okay. Have you ever thought about doing a Pong dress?
We have friends who made a pair of dresses called Gamer Girls. where they were essentially playing a game. The two dresses combined would be the screen, and they had little controllers where
They were using their phones, the
Yeah.
phone app as their controllers, and they're essentially playing like Pong.
or so, yeah. So it was basically they were playing a game with the two dresses. So no, we haven't done that, but somebody already did. It was very, very. They did an incredible job.
That sounds fun.
Yeah.
We've come a long way. We're going from a large console sitting in a bar to somebody who wears a dress.
Yes, exactly. Yeah.
Yeah, the Avatar world there's a comment that Avatar world has a lot of lights. Have we done anything like that? We haven't, but I really think that fiber optics, either as pinpoints of light or kind of the whole fiber, would be really great for like a bioluminescent. So I'm a marine biologist. I do really want to do kind of like an undersea bioluminescent dress. I've definitely been trying to do kind of with this more environmental series that we've been working on recently. I have a couple of things that I want to do for fireflies and for kind of bioluminescent like oceanscape that I'd like to try to do as well. And I think again, the problem with fiber optics is that they're just a really very much a low light scenario. Even kind of ambient inside light is hard to see the fiber optics really well.
Yeah.
I think it'd be kind of fun to do a fiber optic scuba suit.
Oh,
They turn it on and go underwater and confuse the fish.
yeah.
All right.
We make a good acronym.
Any other questions before we sign off? Thanks a lot for doing this. This presentation is being recorded and we'll make it available sometime just after Christmas, as soon as I'm able to get it back up. So Hal and Sahrye have agreed to make it available to the costume community, and thank you very much. And don't forget their book. It's a great book, and I think you'll learn a lot by doing some of the projects in it. You'll get your hands wet, and well, hopefully not wet, not electronics, but dive in and do it. So thanks a lot.
Thank you.
Yeah,
Thanks
thank
for
you.
having us. And we're local to the Bay Area. You can find us online on Instagram at Ampted Atelier. We're glad to answer questions. It will be a costume con over in April. So yeah, we hope to see everyone there.